Good morning. Welcome to Google I/O. I love you guys too. Can't believe it's 1 year already. It's a beautiful day. We're being joined by over 7,000 people, and we are live streaming this, as always, to over 400 events in 85 countries. Last year was the 10th year since Google I/O started, and so we moved it closer to home at Shoreline, back where it all began. Seems to have gone well. I checked the Wikipedia entry from last year. There were some mentions of sunburn, so we have plenty of sunscreen all around. It's on us. Use it liberally. It's been a very busy year since last year, no different from my 13 years at Google. That's because we've been focused ever more on our core mission of organizing the world's information, and we are doing it for everyone, and we approach it by applying deep computer science and technical insights to solve problems at scale. That approach has served us very, very well. This is what has allowed us to scale up 7 of our most important products and platforms to over 1 billion monthly active users each. And it's not just the scale at which these products are working. Users engage with them very heavily. YouTube not just has over 1 billion users, but every single day, users watch over 1 billion hours of videos on YouTube. Google Maps, every single day, users navigate over 1 billion kilometers with Google Maps. So the scale is inspiring to see, and there are other products approaching this scale. We launched Google Drive 5 years ago, and today it is over 800 million monthly active users. And every single week, there are over 3 billion objects uploaded to Google Drive. 2 years ago, at Google I/O, we launched Photos as a way to organize users' photos using machine learning. And today, we are over 500 million active users, and every single day, users upload 1.2 billion photos to Google. So the scale of these products are amazing, but they're all still working up their way towards Android, which I'm excited, as of this week, we crossed over 2 billion active devices of Android. As you can see, the robot is pretty happy too behind me. So it's a privilege to serve users at this scale. And this is all because of the growth of mobile and smartphones. But computing is evolving again. We spoke last year about this important shift in computing from a mobile-first to an AI-first approach. Mobile made us reimagine every product we were working on. We had to take into account that the user interaction model had fundamentally changed with multi-touch, location, identity, payments, and so on. Similarly, in an AI-first world, we are rethinking all our products and applying machine learning and AI to solve user problems. And we are doing this across every one of our products. So today, if you use Google Search, we rank differently using machine learning. Or if you're using Google Maps, Street View automatically recognizes restaurant signs, street signs, using machine learning. Duo with video calling uses machine learning for low bandwidth situations. And Smart Reply in Allo last year had great reception. And so today, we are excited that we are rolling out Smart Reply to over 1 billion users of Gmail. It works really well. Here's a sample email. If you get an email like this, the machine learning systems learn to be conversational, and it can reply, "I'm fine with Saturday," or whatever. So it's really nice to see. Just like with every platform shift, how users interact with computing changes. Mobile brought multi-touch. We evolved beyond keyboard and mouse. Similarly, we now have voice and vision as two new important modalities for computing. Humans are interacting with computing in more natural and immersive ways. Let's start with voice. We've been using voice as an input across many of our products. That's because computers are getting much better at understanding speech. We have had significant breakthroughs, but the pace, even since last year, has been pretty amazing to see. Our word error rate continues to improve, even in very noisy environments. This is why, if you speak to Google on your phone or Google Home, we can pick up your voice accurately, even in noisy environments. When we were shipping Google Home, we had originally planned to include 8 microphones so that we could accurately locate the source of where the user was speaking from. But thanks to deep learning, we use a technique called neural beamforming, we were able to ship it with just 2 microphones and achieve the same quality. Deep learning is what allowed us, about 2 weeks ago, to announce support for multiple users in Google Home, so that we can recognize up to 6 people in your house and personalize the experience for each and every one. So voice is becoming an important modality in our products. The same thing is happening with vision. Similar to speech, we are seeing great improvements in computer vision. So when we look at a picture like this, we are able to understand the attributes behind the picture. We realize it's your boy in a birthday party. There was cake and family involved, and your boy was happy. So we can understand all that better now. And our computer vision systems now, for the task of image recognition, are even better than humans. So it's astounding progress, and we're using it across our products. So if you use the Google Pixel, it has the best-in-class camera, and we do a lot of work with computer vision. You can take a low-light picture like this, which is noisy, and we automatically make it much clearer for you. Or coming very soon, if you take a picture of your daughter at a baseball game and there is something obstructing it, we can do the hard work, remove the obstruction, and have the picture of what matters to you in front of you. We are clearly at an inflection point with vision, and so today we are announcing a new initiative called Google Lens. Google Lens is a set of vision-based computing capabilities that can understand what you're looking at and help you take action based on that information. We'll ship it first in Google Assistant and Photos, and it'll come to other products. So how does it work? So for example, if you run into something and you want to know what it is, say a flower, you can invoke Google Lens from your assistant, point your phone at it, and we can tell you what flower it is. It's great for someone like me with allergies. Or if you've ever been at a friend's place and you've crawled under a desk just to get the username and password from a Wi-Fi router, you can point your phone at it, and we can automatically do the hard work for you. Or if you're walking in a street downtown and you see a set of restaurants across you, you can point your phone, because we know where you are and we have our knowledge graph and we know what you're looking at, we can give you the right information in a meaningful way. As you can see, we are beginning to understand images and videos. All of Google was built because we started understanding text and web pages. So the fact that computers can understand images and videos has profound implications for our core mission. When we started working on search, we wanted to do it at scale. This is why we rethought our computational architecture. We designed our data centers from the ground up, and we put a lot of effort in them. Now that we are evolving for this machine learning and AI world, we are rethinking our computational architecture again. We are building what we think of as AI-first data centers. This is why last year we launched the tensor processing units. They are custom hardware for machine learning. They were about 15 to 30 times faster, and 30 to 80 times more power efficient than CPUs and GPUs at that time. We use TPUs across all our products. Every time you do a search, every time you speak to Google. In fact, TPUs are what powered AlphaGo in its historic match against Laserdahl. As you know, machine learning has 2 components: training, that is how we build a neural net. Training is very computationally intensive, and inference is what we do at real time, so that when you show it a picture, we recognize whether it's a dog or a cat and so on. Last year's TPU were optimized for inference. Training is computationally very intensive. To give you a sense, each one of our machine translation models takes a training of over 3 billion words for a week on about 100 GPUs. So we've been working hard, and I'm really excited to announce our next generation of TPUs, cloud TPUs, which are optimized for both training and inference. What you see behind me is one cloud TPU board. It has 4 chips in it, and each board is capable of 180 trillion floating point operations per second. And we have designed it for our data centers, so you can easily stack them. You can put 64 of these into one big supercomputer. We call these TPU pods, and each pod is capable of 11.5 petaflops. It is an important advance in technical infrastructure for the AI era. The reason we named it Cloud TPU is because we are bringing it through the Google Cloud Platform. So Cloud TPUs are coming to Google Compute Engine as of today. We want Google Cloud to be the best cloud for machine learning. And so we want to provide our customers with a wide range of hardware, be it CPUs, GPUs, including the great GPUs NVIDIA announced last week, and now cloud TPUs. So this lays the foundation for significant progress. So we are focused on driving the shift and applying AI to solving problems. At Google, we are bringing our AI efforts together under Google.ai. It's a collection of efforts and teams across the company focused on bringing the benefits of AI to everyone. Google.ai will focus on 3 areas: state-of-the-art research, tools and infrastructure like TensorFlow and cloud TPUs, and applied AI. So let me talk a little bit about these areas. Talking about research, we are excited about designing better machine learning models, but today it is really time-consuming. It's a painstaking effort of a few engineers and scientists, mainly machine learning PhDs. We want it to be possible for hundreds of thousands of developers to use machine learning. So what better way to do this than getting neural nets to design better neural nets? We call this approach AutoML. It's learning to learn. So the way it works is we take a set of candidate neural nets, think of these as little baby neural nets, and we actually use a neural net to iterate through them till we arrive at the best neural net. We use a reinforcement learning approach. And the results are promising. To do this is computationally hard, but cloud TPUs put it in the realm of possibility. We are already approaching state-of-the-art in standard tasks like CIFAR image recognition. So whenever I spend time with the team and think about neural nets building their own neural nets, it reminds me of one of my favorite movies, Inception. And I tell them, we must go deeper. So we are taking all these AI advances and applying them to newer, harder problems across a wide range of disciplines. One such area is healthcare. Last year, I spoke about our work on diabetic retinopathy. It's a preventable cause of blindness. This year, we published our paper in the Journal of American Medical Association, and Verily is working on bringing products to the medical community. Another such area is pathology. Pathology is a very complex area. If you take an area like breast cancer diagnosis, even amongst highly trained pathologists, agreement on some forms of breast cancer can be as low as 48%. That's because each pathologist is reviewing the equivalent of 1,000 10-megapixel images for every case. This is a large data problem, but one which machine learning is uniquely equipped to solve. So we built neural nets to detect cancer spreading to adjacent lymph nodes. It's early days, but our neural nets show a much higher degree of accuracy, 89% compared to previous methods of 73%. There are important caveats. We do have higher false positives, but already giving this in the hands of pathologists, they can improve diagnosis. In general, I think this is a great approach for machine learning, providing tools for people to do what they do better. And we are applying it across even basic sciences. Take biology. We are training neural nets to improve the accuracy of DNA sequencing. Deep Variant is a new tool from Google.ai that identifies genetic variants more accurately than state-of-the-art methods. Reducing errors is important applications. We can more accurately identify whether or not a patient has genetic disease and can help with better diagnosis and treatment. We're applying it to chemistry. We're using machine learning to predict the properties of molecules. Today, it takes an incredible amount of computing resources to hunt for new molecules, and we think we can accelerate timelines by orders of magnitude. This opens up possibilities in drug discovery or material sciences. I'm entirely confident one day AI will invent new molecules that behave in predefined ways. Not everything we are doing is so profound. We are doing even simple and fun things, like a simple tool which can help people draw. We call this auto draw. Just like today, when you type in Google, we give you suggestions. We can do the same when you're trying to draw. Even I can draw with this thing. So it may look like fun and games, but pushing computers to do things like this is what helps them be creative and actually gain knowledge. So we are very excited about progress even in these areas as well. So we are making impressive progress in applied machine learning, and we are applying it across all our products. But the most important product we are using this is for Google Search and Google Assistant. We are evolving Google Search to being more assistive for our users. This is why last year at Google I/O, we spoke about the Assistant, and since then, we've launched it on Google Pixel and Google Home, and today, it's available on over 100 million videos. Scott and team are going to talk more about it, but before that, let's take a look at the many amazing ways people have been using the Google Assistant. It's incredible when you open source platform and you see what people can do on top of it. We're really excited about the momentum behind TensorFlow. It's already the most popular ML repository on GitHub, and we're going to push it further. We are also announcing the TensorFlow Research Cloud. We are giving away 1,000 cloud TPUs, which is 180 petaflops of computing, to academics and researchers for free so that they can do more stuff with it. I'm always amazed by the stories I hear from developers when I meet them. I want to highlight one young developer today, Abu Qadir from Chicago. He's used TensorFlow to help improve health for everyone. Let's take a look.
My name is Abu. I am a high school student, 17 years old. My freshman year, I remember Googling machine learning. Had no clue what it meant. That's the really cool thing about the internet, is that someone's already doing it, so you can just YouTube it and it's right there. The minute I really saw what machine learning can do, it kind of like hit something within me, this like need to build things to help people. My parents are immigrants from Afghanistan. It's not easy coming in. The only reason we made it through some of the times that we did was because people showed acts of kindness. Seeing that at an early age was enough for me to understand that helping people always comes back to you.
How are you?
And then it kind of hit me in a way where I could actually genuinely help people. Mammograms are the cheapest imaging format there is. It's the most accessible to people all around the world. But one of the biggest problems that we see in breast cancer is misdiagnosis. So I decided I was going to build a system for early detection of breast cancer tumors that's accessible to everyone and that's more accurate. How was I going to do it? Machine learning. The biggest, most extensive resource that I've used is this platform called TensorFlow. I've spent so many hours going really deep into these open source libraries and just figuring out how it works. Eventually, I wrote a whole system that can help radiologists make their decisions. All right, ready? Yeah. I'm by no means a wizard at machine learning. I'm completely self-taught. I'm in high school. I YouTubed and just found my way through it. You don't know about that kid in Brazil that might have a groundbreaking idea, or that kid in Somalia. You don't know that they have these ideas, but if you can open source your tools, you can give them a little bit of hope that they can actually conquer what they're thinking of.
Abu started this as a school project and he's continued to build it on his own. We are very, very fortunate to have Abu and his family here with us today. Thank you for joining us. Enjoy I/O. We've been talking about machine learning in terms of how it'll power new experiences in research. But it's also important we think about how this technology can have an immediate impact on people's lives by creating opportunities for economic empowerment. 46% of US employers say they face talent shortages and have issues filling open job positions, while job seekers may be looking for openings right next door. There is a big disconnect here. Just like we focused our contributions to teachers and students through Google for Education, we want to better connect employers and job seekers through a new initiative, Google for Jobs. Google for Jobs is our commitment to use our products to help people find work. It's a complex, multifaceted problem, but we've been investing a lot over the past year, and we've made significant progress. Last November, we announced the Cloud Jobs API. Think of it as a first fully end-to-end pre-trained vertical machine learning model through Google Cloud, which we give to employers. FedEx, Johnson & Johnson, HealthSouth, Carrier Builder, and we are expanding to many more employers. So in Johnson & Johnson's career site, they found that applicants were 18% more likely to apply to a job, suggesting the matching is working more efficiently. And so far, over 4.5 million people have interacted with this API. But as we started working on this, we realized the first step for many people when they start looking for a job is searching on Google. So it's like other search challenges we have worked in the past. So we built a new feature in search with the goal that no matter who you are or what kind of job you're looking for, you can find the job postings that are right for you. And as part of this effort, we worked hard to include jobs across experience and wage levels, including jobs that have traditionally been much harder to search and classify. Think retail jobs, hospitality jobs, etc. To do this well, we have worked with many partners: LinkedIn, Monster, Facebook, Carrier Builder, Glassdoor, and many more. So let's take a look at how it works. Let's say you come to Google and you start searching for retail jobs, and you're from Pittsburgh. We understand that. You can scroll down and click into this immersive experience, and we immediately start showing the most relevant jobs for you. And you can filter, you can choose full-time, and as you can see, you can drill down easily. I want to look at jobs which were posted in the past 3 days, so you can do that. Now you're looking at retail jobs in Pittsburgh posted within the last 3 days. You can also filter by job titles. It turns out employees and employers use many different terminologies. For example, retail could mean a store clerk, a sales representative, store manager. We use machine learning to cluster automatically, and so that we can bring all the relevant jobs for you. As you scroll through it, you will notice that we even show commute times. It turns out to be an important criteria for many people, and we'll soon add a filter for that as well. And if you find something that's of interest to you, so maybe the retail position in Ross, and you can click on it, and you end up going to it right away, and you're one click away. You can scroll through, find more information if you want, and you're one click away from clicking and applying there. It's a powerful tool. We are addressing jobs of every skill level and experience level, and we are committed to making these tools work for everyone. As part of building it, we literally talk to hundreds of people. So whether you're in a community college looking for a barista job, a teacher who's relocating across the country and you want teaching jobs, or someone who's looking for work in construction, the product should do a great job of bringing that information to you. We are rolling this out in the US in the coming weeks, and then we are going to expand it to more countries in the future. I'm personally enthusiastic for this initiative because it addresses an important need and taps our core capabilities as a company, from searching and organizing information to AI and machine learning. It's been a busy morning. We've talked about this important shift from a mobile-first to an AI-first world, and we are driving it forward across all our products and platforms so that all of you can build powerful experiences for new users everywhere. It'll take all of us working together to bring the benefits of technology to everyone. I believe we are on the verge of solving some of the most important problems we face. That's our hope. Let's do it together. Thanks for your time today, and enjoy Google I/O.